Hi, this is Mike of 71 Squared and welcome to tutorial number 3 of our series on writing an OpenGL game on the iPhone. So first of all, thanks to everybody who's been leaving comments on the blog, having watched the tutorials. It's great to see that people are actually finding them useful and learning from them, because I'm certainly learning while writing them. So thanks ever so much for that, guys. It's much appreciated. And also, there's been some great comments on just things we can, or I can look at improving as well. So we've had Joe on the blog who's made some excellent comments on some best practice and some things that could do with being changed. So what I'm going to do today is I'm going to go through making some of those changes just to tidy up our project, to make sure we're doing things as best as we can at the moment anyway. And then we're going to move on after those changes and actually look at creating our next class as part of our little 2D game engine, which is going to be around sprite sheets. So we'll cover the sprite sheet stuff off in a moment, but first of all we'll just start by tidying things up inside our project as per some of the comments that we've been seeing. So to start that, I'm going to have a look inside our eaglview.m file. And in there is the init with coder class that once we actually, because we're using a interface builder file to actually extract our views, once that's extracted, it uses the init with coder method to do that. And what I've got in here is not only the normal code for the init with coder as necessary to do with the EAGL views, but at the bottom I've been adding my OpenGL initialization code, which you can see here, and I've also been adding my code which is setting up the game. Well, based on the comments that Joe on the blog has done, and also having had a look around, it's not really a good idea to do that. Obviously initializing things in it with coder is fine, but from our point of view, having OpenGL things that are inside init with coder, it's not normally where a more experienced person would go and have a look for code that is OpenGL related. They would expect to find it separated and put with everything else to do with rendering on the screen, etc. So what I'm going to do is I'm going to take the OpenGL code and move it elsewhere, and I'm also going to do the same for the init images code as well, just to keep init with coder nice and clean and crisp, and also make it easy to understand where those other little routines are. Now obviously there are lots of ways of doing what I'm doing around sort of structuring the project. One, of course, would be that EAGL view doesn't really do anything other than set up the main view, and everything else we delegate out to other classes to actually handle our updating of game logic and handling the actual drawing of our view as well. So we delegate that out. Just for simplicity, seeing as I'm learning at the same time here, I've kept it all inside the EAGL view, so that everything is in one place, but we can still neaten this up a bit, which is what we're going to do now. So to start off with, I'm going to move my code for initializing the game here. This is the code that I've got, and I'm just going to move it into a little method which will pop underneath it. And what we'll do is we'll call this init game, something simple. It doesn't take any parameters, and I'll just cut the code that I've got here, tidying up slightly after me, and pop it inside our init game. So that's now been moved, but obviously we do need to make sure we call that. So at the end of here I'm going to say I call init game, oops, like so. Okay, now we have created a new internal method there, so I'm just going to go up to where we've got our private methods, and I'm going to add it up here. Init, oops, init game. Okay, just build that, make sure we haven't introduced anything. No, that built okay. Alright, so we've now done and moved out our init game code, and now we need to do the same with our OpenGL code. So I'm going to grab all of this code here and again cut it out of the init with coder and move down to our render code. So what I'm going to do is I'm going to pop that code that we've just cut into another method, and we're going to call this init OpenGL. Again, no parameters in here. Paste in my code and finish that off. Okay, so we've now popped that code in this separate little method called init OpenGL. Again, if I go back up to the top, I'm going to add that into my private methods. There we go, build, just to make sure I'm all right. Okay, and that built okay. So if we go back down to the render method, now, having done some more research on this stuff and around OpenGL, there are times when you will want to change the projection settings and the model view settings around their matrix in game. Okay, so for example, the GL viewport here, at the moment we're setting that to be the size and the width of the screen, but you can use this to move around a larger screen image or to be able to scale it as well. So for example, if I actually set that viewport and I had the width, half of the width and half of the height, it would actually scale my entire game down to half width and half height. And that might be something I really want to do in the game as part of an effect or as part of gameplay, whatever it may be. So you don't, with those sorts of things, have to set them just once like I am here and then not use them again. Now, just as I'm keeping things simple and we're making a sort of a top-down 2D type game at the moment, I don't currently have a need to actually change the viewport as the game is playing. So I'm going to keep it in here, and basically what this little init OpenGL method is going to do is just set up everything that I only want to happen once. If things are going to change again in game, then I would have the necessary GL commands actually as part of the render loop, so that we're actually changing that as they're needed, as we do, for example, when we set up our image class. As you remember, we actually set it up so that we switch on and off blending as required. We switch the colors on and off as necessary. So, you know, we are dealing with something as a single entity, and it sets up all of what is needed before it draws and then switches stuff off again afterwards so that nothing's left hanging around, ready for the next thing to draw. So you don't have to put everything in here that I've got in here, but for the moment, things like disabling depth testing, setting my blending function, enabling the fact that I'm going to be using vertex arrays to do my drawing, that's stuff I only want to happen once, so I'm going to leave it in here and not worry about putting it in the render loop. Now obviously I need to run it, so what I'm going to do is I'm going to put a little check at the beginning of the render scene here just to make sure that this is actually run, but obviously we only want it to run once. So what I'm going to do is I'm going to create a little variable which we can use to check to see whether this is actually run or not. So if I flick back to our eaglview.h file, I'm going to add something here. It's going to be a bool, and it's going to say GL initialized. Okay, like so. So save that and drop back into my routine. I'm going to do a little check here and say if not GL initialized, then I'm going to run init OpenGL like so, and then finish. So it'll check to see whether GL initialized is set to yes. If it isn't, it will actually run that method, and then what we need to do is when that method has completed properly, is we need to actually set that to show that it's run. So set GL initialized. So what we'll do is, well, the GL initialized equals yes, because that's now been initialized and sorted out. So I'll build that just to make sure everything's okay, and that's fine. So that's now got our init GL routine. We've got it defined up in the interface, and we've got a little check in front of render scene that will make sure that that gets run once. So if I actually run the project now, it drops in there, and we're getting exactly what we did at the end of the last tutorial, but at least we've not broken anything. That's the most important thing for me at the moment. So that draws, which means we're initializing our OpenGL and everything is drawing as normal. So if I drop back into our code again and go back up to our init with coder, we can see that this is now a lot neater. It really does just have what is needed to set up the context and the AGL layer that we're using. And everything around initializing my game is now inside this init game method. and everything around initializing OpenGL is further down inside my init OpenGL method. Now, another thing that I want to cover off is the main game loop here. I've had a few problems where I am in my development cycle, because I'm obviously a bit further ahead, having developed more classes that I'm going to run through in tutorials and actually trying to use them to sort of write game elements. And I found that the way that this is working at the moment with a timer that fires every 60 seconds and calls main game loop is that I was losing touches. I was touching the screen and those touch events weren't getting registered. So I've done some checking around, and I was looking on idevgames.com, and there was a few discussions about this kind of problem on the iPhone. And it basically seems that the way that things run is that there is an event queue or a run loop. And events are dropped onto that run loop, and on like a queue, and they get processed. So as the operating system is running, it will keep looking at the event queue to see what's on there and process the events on that queue. Now with my timer, the NS timer, when it runs, it actually drops an event onto that queue as well, which when it gets picked up, it looks and sees what needs to run, which is my main game loop, and it goes to run it. Now, if I'm now running a very complicated game and there's more things on screen being drawn, we could end up with a situation where it actually takes longer to render the screen than it does than there is time between each of my game loops, each of my 60 frames a second. So before I finishing running the main game loop, NS timer runs again and drops another main game loop call on the event queue. And they seem to be getting picked up before other queue events, such as touches to the screen. So that's why I can end up with the game running, but my touch is not being recognized. Also notice that the game does run smoothly, but there is some jitter and some jumping at times. It's not as smooth as I'd like it to be. And again, this seems to be to do with the NS timer, in that the NS timer is firing and is actually running halfway through the screen being drawn. There's a thing called VBI, or vertical blank line, which is basically the sync. So the screen doesn't get redrawn until the previous draw is finished. Okay, and that just gives us nice smooth screen refreshing. That's hard coded in the iPhone OS. You can't change that. It gives us the nice smooth screens that we see. But what it does mean is that I then start running a main game loop and actually trying to render stuff while the screen is drawing. It doesn't affect what the screen looks like, but it does mean that we seem to get this glitching and this jumping in our game. So what I want to quickly do is just make some changes to the main game loop based on what I've uncovered while having a look around at this. And they're not big changes, and it actually involves removing the need for NS timer. So rather than having a timer that's going to call our main game loop every 60 seconds, we will just loop around inside here, and we'll actually be checking the run loop that the OS has got to make sure that things on the queue are getting processed and have been processed before we run through and do our update and our render. So that has given me back my touches and seems to work great, but also it's smoothed out the screen because we now seem to be in sync with the vertical, the VBL, the screen refresh, and so we seem to have a much smoother screen drawing as well, which is really great, which I'm very pleased about. So if we make some changes here, the CF time interval and delta for the float, they remain unchanged. But what I am going to do is I'm just going to have a while loop, a very simple while loop that will just keep on running. Inside this while loop, we're then going to have another while command, and this while is going to be running, and it's going to be looking at this run in mode, this CF run loop run in mode. Now I'm still sort of getting used to what this is doing, but it's basically this command is basically going to say go and check the run loop and the event queue that's in there, and make sure everything on that queue has been processed before processing our screen. Which means that it's going to make sure that the screen has been finished drawing. It's going to make sure that our touch events are handled, and from reading the documentation, that seems to be what it does. So I've got the mode here. The reference mode that I'm going to be running in is going to be the default mode. So this is run loop default mode, and the time interval in seconds that seems to work for me is 0. Okay, and I'm then going to have true in here. Oops, okay, and then we'll say equals, and then it's kcf run loop run handled source, like that. So that's the command we need that will just sort of keep looping through until the events on the run loop queue are done, and then it will pass back control to us, and we then go along and update our scene, render our scene, and then it happens again. So the time and the delta calculation stay the same, although I have done a multiply by 1,000 on this, just to give us smaller numbers, or just so we can use smaller numbers when we're updating our logic and our things moving around. It's really just a personal preference, really. You could not have the times 1,000 and just be using different numbers in our methods for moving things around. We're going to be worrying about that later when we actually start looking at the actual game itself, but it's just something that I've made a change to in my other code, so we're reflecting it in here. And updating the scene and, oops, I just skipped way too far. Updating the scene and rendering the scene are also going to still be in there, and then we close off the loop. So our while loop is going to be, in fact, I closed that off too early. I need to make sure that I include the last time in there as well. So our while loop is going to just be flying around this while loop here, and this while is going to be just making sure that everything on the queue gets run, which means that our touches don't vanish, and it also means that we seem to be in better sync with the screen and we get less jumping, which is great. Now, having done that, we'll do a quick build just to make sure that nothing has been introduced in terms of errors. So the build has worked okay anyway. But it means that we don't need our NS timer anymore. So we can start to move through our methods to remove anything related to NS timer. So we'll start at the top here. And we've got this inside our private interface here. We've got animation NL timer. So that can be deleted. Okay, we're not going to use that anymore. If I move down, I've got the animation interval and animation timer. They can both be deleted. Okay, and then I'll start moving down. There's nothing around animation up here, all apart from inside init with coda. We don't need to set the animation interval anymore. That can be removed. Okay, and we'll carry on going down. There's our main method loop that we've just run through. That's fine. Our update scene is okay. Render scene, nothing in there. Init OpenGL, nothing in there. Okay, I see this sometimes. Sometimes Xcode can sort of have a bit of a fit when you've shrunk down methods that are like that. You know, you can sort of collapse them, and you have to sort of open and close them and open them again to get them back. As you can see there, it sort of does a bit of doesn't like that all the time. But what we can see down the bottom here is I have got the start animation, stop animation, set animation timer, and set animation interval. These are no longer needed either, so I can delete all of those, which we can do like that. Okay, so that's those gone. So that's everything inside that eagl view.m file. So I'll save that and then flick to the eagl view.h file. And again, in here, we can see that we exposed the stop and start animation methods. We don't need those, they've gone. We had a property here for animation interval. We don't need that because that's been removed. And that means we can also get rid of the animation interval and NS timer definitions as well. So that's those gone. Okay, so I can save that. And I think the only other place that we need to look now is inside our app delegate. Okay, because in here, we were setting the animation interval, which doesn't exist anymore. So we can go in here and remove those settings. And we haven't got start animation, that can go, so they can be removed. But what we do have to do is we have to run the main game loop. So what we'll actually do is go back into eagl view h, and we'll add main game loop as an external, main game loop as an external reference. Save that back into the ogl game app delegate.m file, and in here we will say glview main game loop, so we can run that. So when the application has finished loading, it will run the main game loop inside our GL view, which is actually eagl view.m. Now, because eagl view.m will have already been instantiated, it means it will have already run through our initialization code. So init with coda would have run, which in turn would have run init game. Okay, and then when our main loop runs, it will check to make sure that all the queues are empty, and then it will work out the time, run update scene, and then run render scene. And with the other changes that we've made, when it runs render scene, the first thing it will do is it will check to see if GL initialized is set. If it isn't, it will then initialize our GL code and then start rendering from that point onwards. Okay, so one thing we do want to do, just to make sure that things are working properly, is back up inside our init game code here. We'll just make sure that we've got GL initialized equals no. Okay, so in other words, the first time we run the game, we actually set that to no. So we're forcing it to run that init OpenGL method. So I'll save this and I'll build to see if we have any errors. And I've got one error here, or one warning here. And okay, inside our dealloc method, we're doing a self stop animation to stop the timer. So I shall remove that. Okay, build again. Okay, and that's built with no errors. So we'll run and we'll see what happens inside our game. So there we go. It's not very exciting. It's the same thing we've seen, but it means that it's rendering. So that means that our wiring up that we've just changed is working and the game is still rendering. So that's really all I needed to do in terms of just tidying up the project a little bit. So we've now got it to the point where we've tidied up init with Coda, we've broken out our init OpenGL stuff, and we've also made that small change to the main game loop, which will stop us from losing touches, which we obviously need because we want to be able to fire and things like that, and has smoothed out the gaming as well, so for when we've got animation running. So what we can do now is move on and actually start looking at building our SpriteSheet class, which isn't very big, won't take very long. But what it's going to do is it's going to let us access images within a single texture just by specifying their X and Y coordinates, or their column and row coordinates. And this is going to be really useful going forward because you may want to have a large sprite sheet which you just grab images from and render them to the screen. But when we get to animation, where you've got a number of frames that you want to play through, then you can have a sprite sheet that defines each of those frames. And when you set up your animation, you just literally say, row 0, I want to get an image from column 1, column 2, column 3, column 4, and so on. And it just makes it nice and easy to go and grab images from a sprite sheet. Okay, so what we'll do is we'll get on and actually write that now. So what we're going to do is inside our engine directory here is add a new class. Okay, so it's going to be iPhone touch class and then this object. Okay, and we're going to call this SpriteSheet. Okay, that's what we want. So there's our SpriteSheet object, and there's going to be a number of things that we want to have inside our SpriteSheet. Okay, so for example, we're going to want to have an image file that we can reference, sorry, an image instance that we can reference to actually go and grab our sprites from. So because we're going to need to access our image class that we've already written, I'm going to import our image class so that we've got access to that. Okay, and then down inside our interface, I'm going to specify image, and we'll call it image. That's going to be the image or texture that is going to be referenced inside our sprite sheet. We then need to know what the width and the height of each sprite is. So the way that this is going to work is that we will need every sprite on our sprite sheet to be the same width and the same height. That doesn't mean that they have to be 32 by 32, they could be 32 by 10 or 12 by 16, but every single sprite has to have those same dimensions because we're going to use the width and the height when calculating whereabouts on the sprite sheet to go and grab an image from. So I'm going to use a GL uint, so an unsigned integer, because they're only going to be positive numbers, and we're going to have sprite width, and we're going to have the sprite height as well. Okay, so the width and height is going to be stored, and we're also going to have some spacing in here as well. And what I mean by spacing is how many pixels are there between each of the images, each of the sprites in our sprite sheet. Because you may want to have spacing in there, you may use a tool to generate your sprite sheet that inserts spacing. So just so that we can handle that, we'll be able to have spacing as part of our calculation inside our sprite sheet class. So now we've got that, what I'm going to do is I'm going to start setting up the properties that we're going to be able to read, because we want to have getters and setters in here. So the image is going to be a read-only image, okay, because we just want to be able to access it. We're not going to want to actually change it at all. That's not going to be allowed. That's you only create the image when you create the sprite sheet. You don't make changes to it any other time. We're then going to have, oops, the sprite width. Again, read only. We don't want to make changes to that, otherwise that will muck up all of our calculations that we're going to be doing to calculate where things are. So we're also going to have sprite height, which is going to be on there, and we're also going to have access to, again, read only. Oops, daisy. Read only, and again glue int, and this is going to be our spacing. Right, now we can start to create our classes that we're going to expose. So we're going to have a few initialization classes in here. So what I was thinking when I designed this was it would be good to be able to initialize a sprite sheet using an image that we've already created. So literally you just pass in a reference or a pointer to an image that already exists, and also be able to just pass in the name of an image file that we've got, and it actually goes and initializes that image as part of the sprite sheet, just to sort of help us actually do that. So convenience initializers really. So the first one, I'll do init with image. So this is going to actually take reference to another image. So that's going to be an image star, and we'll call that the sprite sheet itself. We also want to be able to take in the sprite width, which will need to be a glue int, and we'll call that width. And we want to take in the sprite height, again unsigned integer, and that's going to be height. And we also want to take in the spacing as well, and there we go, we'll call that space. So that's our initializer for the init with image. But now I want to have one which I'm going to say init with image named. Okay, so this one now is going to take an NS string, and we're actually going to call this sprite sheet name. Okay, so that's going to just take a name of a sprite sheet. We still want to know the sprite width, so that's going to be the same width, and we still want to know the sprite height. Okay, so we'll add that in there as well, call that height. Spacing is still important as well, so we'll have spacing in here. That space. But what I'll do, I'll add one called image scale as well, because when we're able to call that scale, when you actually create an instance of an image, you can say you want to scale the image up or down as part of that initialization. So if we're actually initializing an image within the sprite sheet method, because we're just passing it a string, it'd be good that when we do initialize that image, we can do something similar and pass in a scale, so that sprite sheet can be scaled up. So that's why I've added scale to the end here. The last method we need to worry about is we want to be able to get an image at a certain location. So we'll be passing back an image reference, and I'm going to call it get sprite at x, and x is going to be again a unsigned integer, and we'll call that x, and y is the same thing, and we'll call that y. So we've built our project. We've got a few warnings, which is to be expected because we've only defined the header and not the implementation at the moment. So the implementation is what we can do next. I'm going to do the same now as I did in the last tutorial, and actually cut and paste in the code here, just so you're not sort of watching me type in the code as we go, but obviously we'll go through and discuss what the code is doing. Okay, so inside our.m file, I've already started to put in some of the code here that we actually need. So if I just actually remove something here that we don't need. So there's a private method that we need to create, which is called initImpl, and what this does is it just gives us a standard place where we can define things like width, height, spacing, and image scale inside our implementation. Because we've got two initialization methods, we want to do the minimum things in there, and those are things that are unique to that implementation. Everything that is common across the implementations we'll put into one method, which is called this init implementation here. So we've done that, we've created our interfaces. So the next thing we need to do is we need to actually pop in the synthesization, or we need to synthesize our properties, which we've got there. So that's the image, the sprite width, sprite height, and spacing. Next, I'm going to put in our init with image method, and this method was the one that allows us to specify an image that already exists. So if I drop that in here, So this is taking an image that already exists and is referencing it, and then takes the width, the height, and the spacing. So inside the initializer, you can see that the image for our sprite sheet is just referencing the image sheet that's been passed in, or the image that's been passed in. Because of that, I'm doing a retain on that image. If the image outside of the sprite sheet was released, and that meant that it was actually deallocated fully, when I went to try and access it from inside the sprite sheet, it would fail. I'd get a bad access memory or bad memory access error. To try and stop that from happening by mistake more than anything else, because we should know that it's going to do that if obviously we've written everything, I'm adding my own retain to it. So I'm upping the retain count by 1 here because I am using this image inside my class. So even if that image is released externally to the SpriteSheet class instance, I should still maintain that particular image in memory because I've got a retain against it. It's only once I hopefully release this class that retain would be released, and at that point it would probably go to 0 for a retain count, and then it would actually get removed from memory. So that's why I've got an image retained there. And then at the end of this, I'm calling the implementation. Okay, so I'm passing in the width, the height, the space, and the image scale for that to be set as well. So the next thing that I need to do is just pass in the inImageWithNamed method, or init method, which we need. So I'm going to drop that in there like that, and we can start to run through it. So inImageWithImageNamed is not being passed an image or a reference. It's actually just being passed a string, which is the name of the image file that we want to load. It's then getting the width, the height, the spacing, and the scale. The reason I've added scale here is that because we're not actually passing in an image that's already been created and therefore could have had scale set, this is going to be a new image, and therefore we want to be able to maybe set the scale of that image as part of the initialization. You could always set and change the scale as well as the color filter and the rotation and everything else to this image externally through the sprite sheet, but I just wanted to, for convenience sake, put the scale as part of the method signature. So in here you can see that we're actually creating a new image and allocating it, and we're doing that with the inItWithImage initializer for the image method, image class, so that we can just pass in the sprite sheet name, and we're passing through the scale as well. Once we've done that, again, we go and call the implementation, which handles the rest of the initialization, which is the next piece that we'll actually go and put in. So we'll drop this code in here. Okay, so this is our initialization code. So we're getting the width, the height, the spacing, and the image scale, and we're just setting those. Okay, so that sort of finishes everything off and gets that done and out of the way. Okay, so once we've done that, the next thing we need to sort out is we need to think about the image itself, getting the sprite. And what we're doing is we've got one method to do that, which is this getSpriteAtX method. So if we drop that in, we can have a look at it. So here we go. That's the method itself. And what we can see here is that we're passing in an X and a Y coordinate, and we want to be able to use that to grab or return an image of that X and Y. So the first thing we're doing is we are creating a point called SpritePoint, which is calculated by using the width and the X and the Y coordinate sent in, and we then use the sprite width and the spacing to find out where within the sprite sheet that we're using we actually should start to grab the sprite from. Okay, so the X coordinate is going to be, I want sprite 0, 1, 2, 3, 4 along the sprite sheet, and Y is I want sprite 0, 1, 2, 3, 4. So it's columns and rows, not pixel locations. By multiplying that X and Y value by the sprite width and the spacing, that does turn it into the pixel dimensions that we're actually going to use to grab that image from within inside our sprite sheet. Okay, once we've done that, we then just return the image. So we use the getSubImageAtPoint method within inside the image class, and we pass in the sprite point, which is the pixel point, if you like, that we've just calculated, which is where we want to grab the sprite from. And we use the sprite width and the sprite height and the scale to then grab a piece of the image that we're using, so a piece of the sprite sheet that we're using. Now, this does send back a completely new image that's been allocated and created, so a completely new instance of image, but it doesn't, as part of that image, have a completely new texture. So if we were to actually go and have a look inside the image class, and we went down to look at the, where are we? Going down, get subimage at point. Okay, so this is the method that we're actually calling now. If we had a look at that, we'll see that we're creating a new instance of image called subimage, but we're using the initWithTexture initializer, which means that rather than actually creating a brand new image inside this instance of image, we're actually just passing in a reference to a texture that already exists. Okay, so the instance of image we're creating will have all its own parameters, which allows us to define, for example, the area of the texture that should be rendered when we ask it to render. But the actual image that it's using is an image that has already been created into a texture. So we're just referencing an image that's there, not creating a new instance of it. And that's just so we can keep memory down. We don't, for every single sprite that we go and ask for, we don't want it to create a brand new instance of image, including a brand new texture to go with it, because that will just consume memory really quickly. So that's how we're managing to reference a texture and not just create textures one after the other. So if I go back into SpriteSheet.m, that was the get subimage at point that we've created. And that's really it, apart from we just add in now our deallocation method at the end here. So if I just grab that and pop the deallocation method in like so, you'll see that when we release, or when we deallocate this class, we release the image lock that we have, because we're either going to have our own image or we're going to have an image externally, which we've retained. So for either of those, we want to remove our count on that, our image count, retain count, and then we deallog. So if I build that now, we can have a look and see what happens. So that's built and we have no errors, which is always good. And that's really our SpriteSheet class. It's very straightforward. But what we now need to do is we need to actually grab an image, which is a SpriteSheet, so that we can try it out. So I've got a sprite sheet that we're going to use, which is some sprites that were actually taken from an old classic 1980s game, very famous game, called Xenon 2 Mega Blast, which was on the Amiga, the Atari ST, and a number of other consoles at the time. Great game, one of my favourites, which is why I like using the sprites of it. And so they're the ones that we're going to use because I have no graphical capability at all in terms of drawing my own things, so we'll use that to make it a little more attractive. So inside our image folder here, I'm actually going to go and add an existing file, and if we look inside our graphics, inside my graphics folder here, we've got this GIF file, okay, which are the sprites that we're going to actually use in here. So if I add that, okay, and I do want to have a copy of it, and what you'll do is you'll find that on the project that is posted to the blog, this image will be included. Okay, so you'll have this sprite sheet as part of the project for the third tutorial on there, so you'll be able to grab hold of it. If I click on that and have a look, you'll see that it's a bunch of sprites, and these are animated sprites as well, because obviously we're going to be creating an animation class as our next tutorial. So for this particular class here, you can see that each of these is 16, which is why it's called SpriteSheet 16. Each of these sprites is 16 pixels by 16 pixels. And you can see that as they go along, the images change slightly. So if you were to sort of just run these through, you would get an animation. But what we're going to do, just because we've got our sprite sheet working, we're just going to use that to just grab a particular sprite off here and render it, just to show that we can grab any one of these images very easily off the sprite sheet using our new sprite sheet class. So we'll go and have a look inside the EAGL view, and in here we're going to actually create the code which will initialize our sprite sheet and allow us to go and grab any sprite that we want to actually render it. So what I'll do is, after the bit of initialization code that I've got, which is up here inside init game, in fact, let's in the header first, let's go and create a sprite sheet. So we need to add our or import, sorry, our SpriteSheet class so that we've got access to that. And I'm then going to create something called SpriteSheet, and I'm going to call it SS, SpriteSheet. So I'll save that, drop back into the .m file, and I'm going to say SS equals SpriteSheet, and I'm going to say allocate memory for that, and I'm going to go init with image named. Okay, so I'm going to just give it the name of our image, and that's going to be SpriteSheet16.gif here, and I'm then going to give it a width, which as we said was 16 pixels wide, sorry, by 16 pixels high. Now there's no spacing in here, so they're literally, the images are right next to each other, so we have 0 for the spacing. And I'm going to say that I want to bring this in, and I'm going to have it twice the size that it is on the sprite sheet, so I'm going to do that. Okay, so there's our initialization of our sprite sheet using the sprite sheet class that we've created. Very straightforward. So I'll just build that to make sure nothing has happened, and it has. And the reason is that when I did my header, I didn't create it as a pointer. So we'll save that, drop back, and build again. And there we go. That's built that time all right. So now we've got our sprite sheet. If I drop down to our render routine, we can actually start to render a sprite based on an X and a Y location. So what we'll do is, first of all, we'll have a look here at the sprite sheet, and it starts at 0 because it's run off of an index. So if I say I want to have, let's have a look, this chap here, I want to render this guy here onto the screen. So that's 0, 1, 2, 3, 4. So Y would be 4, and it's 0, 1, 2, 3. So it'd be X is 3 and Y is 4 to grab that guy there. So we'll go back over here, okay, and I'll say SS, and in fact, no, what am I doing? I need to create an image of that first, don't I? So go up here. Again, we'll create a quick image up here, and we'll call this sprite, like that. Save it back in here, and I'll say that sprite equals SS get sprite at, and we said it was going to be X was 3 and Y was 4, like so. Okay, so that puts the sprite at that coordinates from our sprite sheet into this property here. So we can go down and we can actually then render that to the screen. So I can say sprite render at point CG point make, and we'll do this at I don't know, just 50. Okay, and I'll say yes, we want it to be rendered in the middle there. So that's everything. If I hit save on that and build, it's built all right. So we'll now hit run as well, and we should, there we go, we got our little character on the screen. So there's that particular image that we wanted out of our sprite sheet, which we can now move around. So sprite, whenever I render him, will render that particular image. I could change that very easily. So if I actually go back up to the definition point here, and instead of saying 3, I say 0. Save that. A quick look at the sprite sheet will say that 0 should have the guy with his tail to the left, as he's got there. Okay, so we'll run, and there we go, that's the guy with his tail to the left. So it's really simple now to just go and take a sprite sheet and grab any image you want from the sprite sheet. Okay, because let's just try another one just to make sure. We'll try one further up the sprite sheet. So this one we'll actually say is, let me go back, 2. So I'll say it's going to be X of 4 and Y is going to be of 2. And we run that. It should be part of the explosion. And there we go. That's part of the explosion sprite. So that's it. That's us getting our sprite sheet working using any sprite sheet that we want to create. It makes it really simple to go and then have a single image containing all of the other images we want to play with. As I said earlier, the limitation is that it has to be the same dimensions for each sprite. But what we'll do later on is we'll change this, and we'll actually have one image, and we'll get to embed a sprite sheet within a sprite sheet. That's just a little bit more work, so I haven't done that at the moment, but later on we'll do that so that we could start to have different sprite sheets of different dimensions all within one big sprite sheet, which we can go and grab hold of, and we'll get that working. The one thing I will just mention before I finish on this one is obviously I put in here an image scale, and you can change that image scale at will. So if I put in an image scale of 1, and we run the same thing again, we'll get it at actual size, which is obviously much smaller. If I put in an image scale of 5 and run it again, we'll actually get a much larger. There we go, it's much, much bigger. So it's quite nice now. The image class and the SpriteSheet class are working well together so that we can really muck around and have quite a lot of flexibility in what we do. But as you can see, the actual definition of a SpriteSheet is very basic. The creation of an image from a SpriteSheet is really simple, and then you just render it as you need to. So hopefully that's made sense, and that you'll see how we can use the SpriteSheets now. So have a play. As always, if you have any comments or anything you want to bring up, let me know. And the next tutorial, which I'm going to try and get out as soon as I can, will be on animation. So that's where we're going to be able to take the SpriteSheet and use that to then create a nice animation, so we can actually flick through those images on screen to get the animation that we're after. So that's the next tutorial, so watch out for that. It should be around soon, and I look forward to talking to you then. So thanks very much.